Hey everybody, so we've reached the halfway point in the course, and I thought it might be useful to write a little program that uses everything we learned so far, just so that we can see the combination of all the different topics before we move into object-oriented programming. So we're going to be using conditional logic, we're going to be using arrays, we're going to be using loops, obviously we're going to be using variable declarations and assignments. We're going to be doing input-output, and we're going to be using operators, expressions, pretty much everything we learned in the first half. So let's get into it. I guess let's just look at the way the output works to give us an idea of what we're writing. So I've drawn a little chessboard here. As you can see, the name of my fiddle here is almost chess. It's not really chess, but it looks like it right now. So we have all of our pawns here, we have pawns here, and then here's all of our pieces in the back rows. What this program will do is it will take a target row. So I'm going to try to move the bottom queen, which would be a row of 8, and the column 4. And then it asks me for the destination row and the destination column. So I'm going to take my queen and I'm going to move her. Actually, there's no rules. That's why it's almost chess. So I'm going to take over this pawn over here, the far right pawn. So row 2, column 8. Now you'll notice my queen moved. She's gone. And she ended up in 2-8. And that's all this program does. It will take whatever target row and column you specify, and it will remove it, and it will place it over whatever was in the destination row and column. So that's cool. So how does it do it? Well, the main program actually starts right here. Everything above it is just method declaration. Well, this too, but we'll show that in a second. So it says bool done equals false, set up the board, and while you're not done, print the board, get those numbers from the user, the target row, target column, destination row, destination column. And then, okay, now we have what it looks like indexing a double two-dimensional array, which is the board. So we kind of have an idea of what's going on here. It's initially setting up the board once, and then continuing to iterate by printing the board, getting our user input, and then making changes to some type of data that's going to affect the next time we print the board. So with that perspective, let's go back and see what we've done. Well, it starts to make sense already on the first line of code. There is a two-dimensional array. You can actually have an array with as many dimensions as you want, but I don't want to mess up your brain, so we're going to stick with 2 dimensions. And this isn't really that hard when you think about it because it's just an array of size 8. Well, that's pretty easy. There's 8 things in the array, but instead of 8 integers being in the array, there's 8 arrays inside of the array. So if you just, even if you just look at the board, it's pretty simple. These are this actually is the value inside of the first position in the array. Well, what is that value? It's an array itself. So you can have an array of arrays, and to index the array and then index the integer inside of that array, you would simply say, well, the first array contains arrays. So the first thing I want to do is pick which array out of all of these arrays that I want to look at. So that's what the first number does. The first index says, which array am I talking about? So if you say in the first position board sub 0, you already are talking about this array. Now, since you have that array, you can say position 4, and that would give you the queen. So 0, 4, let's see, 0, 1, 2, 3, 4. Yeah, that's right. So board sub 0 sub 4 is this position right here. It's this value right here. But notice they're integers, they're not strings. So we'll come back to that in a second. So I have an 8 by 8 grid, if you will, of numbers, just plain old integers. So there 0 through 7 are the indices, going both vertical and horizontal. And then I write a loop that says I want to iterate 7 times, and this is just declaring memory. So it says for each of the 8 positions in my array, I want to create the array. So once again, that's exactly what I was just talking about. Here's the first position, I want to create an array. Second position, I want to create an array. Third position, I want to create an array. So that's just saying declare memory for my arrays. So if you recall, we called this method setUpBoard once. This was the first line of code basically in the program. So what did it do? It's a double loop. And once again, once you memorize the form of the double loop, you don't really even have to look at it. You just look at it and you recognize that it's a double loop, and then that leads you to recognize that anytime you refer to the two-dimensional array sub I sub j, that means it's doing this thing for every element in the two-dimensional array. So you don't even have to think about that code right there. This just means I'm doing something to every position on the board in English. And once you recognize that pattern, you don't have to think about anything. You don't have to think of you don't have to look at all these different little aspects of the syntax, because this is a pattern. It just means do this for everything in the array. So the first thing it does is it sets the whole board to 0. So there's just zeros in every single position, in every single position in every array. So that sets 64 times, that sets the current position in the 2D array to 0. So if I had nothing but that, I would have 64 zeros in a two-dimensional array. 8 by 8, zeros in every position. However, after I fill it with zeros, I'm coming around and doing some other things. This first statement's a little interesting because I'm saying if I equals 1 or I equals 6, then I'm going to set that position in the board to 1. Well, I actually refers to the row, so that would be I equals 1 would be right here, because the one above it is I equals 0. And I equals 6, I equals 6 is this one right here. Because remember, everything is 0 based, so you have to subtract 1. So what did I just highlight? That and that. So those are the pawns. So when the row is 1 or 6, those are the pawns. So I'm setting those to 1. So you can kind of see here implicitly that I'm saying 0 means there's nothing there, 1 means there's a pawn there. So this whole group of code here is just setting the remaining pieces. So if you look at these 4 lines of code here that end in equals 2, that would be 0, 1, 0, 6. So row 0 is here, 1 is here, 6 is here. So those are the knights. Couldn't say K because K is the king. So these 4 right here are the knights. That's number 2. The value of 2 represents a knight. 0, 2, 0, 5. So 0, 0, 1, 2. That's a bishop. 3, 4, 5, bishop. So I'm setting the bishops here. So 2 is the knights, 3 is the bishops. I'm going to go ahead and guess based on the rest that 4 is the rooks, and 5 is the queens, and 6 is the king. Let's just verify that with this last one here. 0, 3. 0, 0, 1, 2, 3. So that is the king on the far side. So if memory serves, it looks like I said the 4 knights, the 4 bishops, the 4 rooks, the 2 queens, and the 2 kings. So that's how I'm setting up the board. So it's not that bad. And now I have the transformation. This is why I can see letters on the screen instead of numbers. I wrote a little function here that says you give me a number and I'll give you a string. And I simply said if I is 1, return P for pawn. If I is 2, return N for knight. If I is 3, return B for bishop. If I is 4, return R for rook, and so on and so forth for queen and king. If I returned anything else, in this case I'm using zeros for the other spots, but if I return anything else, it's going to give me a blank space. So that would be all of these right there, which are zeros. And the print board should not be a huge surprise. It's just a bunch of text to make it pretty. There's only one real thing of consequence here. If you get rid of all the pretty stuff and you boil it down to all that is really there, you basically have what I showed you before, nothing but the same exact pattern of the double loop with I and J and indexing the board with I and J. So this in English just says whatever this line of code does, do it for every element in the board. And what is it doing? It's calling display value, which actually it's writing display value to the screen, which is that whatever number is in the current position of the board translated as a string or as display value. So this is nothing but, once again, the same exact code, the same I for loop, the same internal J loop, and the same accessing of the current position in the 2D array. So that's how it redraws the board every time. I just will take 1 minute to note one thing. The only thing that changes the behavior of print board is if the data inside of board changes. It's printing things to the screen based on what is inside of the board array. So that kind of introduces this concept of state. And state is important right now because as we move into object-oriented programming, everything is based upon state. This is the state of the board. Now we could do things with it, but if we don't print anything to the screen, the user won't see anything. So as you progress in programming, this is very, very important to understand. As you progress in programming, there will usually be a concept of a distinction between what you see and the underlying data that what you see is representing. So that's kind of the concept of state. What you see on the screen is just a user interface or pretty pictures or anything, but it's based on data. And when the data changes, what you see changes. That's why they call it stateful. This is the current state of the board. Changing the state will change what they see. So by changing the values inside of the array and then calling print board again, we get to see the new updated board because print board automatically adjusts itself and its behavior based on the state or the data. So that is probably the most important thing that you can glean from all of this is the way I've designed the code. I've separated the state from the UI. I could remove the UI completely. The user wouldn't see anything, but I would still be able to write a lot of code that set up the data for the board and manipulated it, and then I could write a completely different set of code that handled the UI. I could write 3 different sets of code that all had different UIs based on the same single source of data. So I could use this board to print out the board 17 different ways. So that's very, very important because once again, we're going to come back to the topic of this state or this data controlling or driving either the way something behaves or the way it looks. So it's an important concept to understand. So how can done become true? So I didn't really write that part. So I guess I didn't really put any error handling in here. I think the best way to hack this up really fast is to just get rid of the not done. Just say while true. So now I have a loop that goes forever. I'll just put some hacky code in here that says if target row is less than 0, which is bad, or target row is greater than 7, which is bad, then return. So that should just bust us right out of the program if anything is wrong. Not really great code, but I'm in a little bit of a hurry right now. So let's see if that works. So I'll do good things, 1, 1, I'll do another good thing, and then I'll do bad thing, 9, and see what happens, and it does bust out of the program. So I got rid of all that complicated stuff, and I just kind of put in some hacky code to make sure that the user doesn't type in anything that's out of bounds. It has to be between 0 and 7. All right, so that's pretty much the whole program. Hopefully most of it makes sense to you, and we can talk about it more in class. We could discuss it on Blackboard. There's definitely things that I did here that are kind of hacky. There's things that are not that great. But remember, like I said, once the user enters these 4 numbers, all we're doing is we're adjusting the data. So the first thing we're doing is we're saying, well, the user said this was the target, so let's go to that place in the array and figure out what value that is. So it remembers that number. Now this doesn't alter the state. This is just remembering the number that was in the target position. But now we have 2 adjustments of the target, and a nice big word in programming that we like to use for this is mutation. I can't spell at all today. I can't spell or type. Bad combination. Mutation, and more than mutation, but state mutation. Mutation. Yeah, I spelled it right. So mutation just means change. So we change the state. So the destination is given the value of whatever the target was. So if we're moving the queen, now the queen replaces whatever is in the destination in the state, and whatever position we just moved, we blank that out because the queen has just, in this case, left where she was, and obviously if she left, there's nothing there anymore. So this is the big, these 2 lines, especially this one, are the big state mutation. And after executing those 2 lines, when we loop and come back up here and we redraw the board, it's going to redraw it based on the updated state. And as you saw, the queen had moved. The place she was at was empty. And we have our classic example of the UI being based on the state and updating based on changes or mutations in the state. All right, that is all I'm going to say for now. And I think we can ask questions on Blackboard. I wrote this. I didn't try to write this with super high quality. I wrote this as fast as humanly possible. So I totally understand if you think the code sucks, because it probably does. But I'm sure if we tried to clean it up together, we could, and maybe we will. So we'll see. But once again, this is just to kind of overview every concept that we learned in the first half of the course, and I hope it served that purpose for you. All right, thanks.